where he focuses on uncovering the root cause of security incidents and safeguarding organizations from emerging threats. With a career dedicated to leading top-performing incident response teams, managing security operations, and conducting in-depth forensic investigation, Tyler has built a reputation as a trusted expert in the field. Outside of work, he enjoys immersing himself in RPGs and board games, combining strategy and creativity in both his professional and personal life. And we would like to thank him for being a speaker this morning, so thank you so much. And I will turn it over to Tyler.
All right, thank you, everyone. Could you tell that that bio was written by our marketing team? Yeah, again, I'm Tyler Hudak. I've been doing IR and forensics for a while. I've been in security for a while. One of the things that I love is kind of diving into new things. Looking at the way that attackers are doing things and seeing how, from a IR or forensics perspective, how can I figure out what happened? And that's what this really talk is about, is Microsoft Quick Assist, which we'll talk about, what it is, why do we even care about it, how are attackers using it, how does it work, and more importantly, if you see something bad happening with it, what can we do about that? What can you figure out? I will say, excuse me, this is a work in progress. I'm still doing research on this. My next steps are basically to break open the executables and start doing reverse engineering on them to try to figure some things out. So I will likely, be publishing more of this in the future. This presentation is at my GitHub. There's another link at the end if you all want to see it. But let's jump into it. So Quick Assist is an RMM at its core. If you're not familiar, RMMs are remote monitoring and management tools. These are tools that allow administrators to connect or manage or monitor endpoints so that they can easily do that within an organization. So, for example, we have our user here who needs help. They call IT and say, hey, can you connect to my computer to fix it? And understand, within an organization, within an internal network, yeah, they could just use RDP to connect to it. But what if that user is at a conference? What if they're working from home? What if they are halfway across the world at a Starbucks? The IT can't just RDP to that, and that's where RMMs come in. So the IT will use the RMM interface to connect in to the system, monitor it, manage it, get a desktop, get onto the desktop, and so on. This is a very simplified view of RMMs. They do a lot more. So when you think of things like Ninja RMM, TeamViewer, a bunch of others, Kaseya had a big breach a couple years ago, I think, a year or two ago, which led to a lot of bad things happening. But RMMs, this is what RMMs typically can do. Microsoft Quick Assist is an RMM at its heart. You have a sharer. This is the person who wants somebody to connect to their system, and you have the helper. This is the person who's going to connect to the system. These are Microsoft's terms from their documentation. So in this case, if the sharer wants help, the helper will open up Quick Assist. They'll click a little button that says, I want to help somebody, and they will get this code. The sharer, they give this code to the sharer. The sharer enters it in, and then a connection is made between the two. We'll talk about where those connections happen in a little bit. And the helper is then able to see and access the desktop of the user. So a little bit of history, because this is going to become important later on. Quick Assist hasn't been around forever. Back in the Windows XP days, we had remote assistance. And remote assistance basically was a front end to RDP for the most part. That you had to have 3389 opened up in order for remote assistance to work. Moving forward with Vista, it upgraded to have the nice little GUI that we have on the right side. Some additional features were added in. Quick Assist wasn't introduced until Windows 10 Anniversary Edition. Remote assistance is still present on Windows 10 and Windows 11. It's just hidden. If you go to the Start menu and type Remote Assistance, it will actually pop up, you can still use it. But Quick Assist is what is normally used now. It is installed by default on Windows 10 Anniversary Edition and Windows 11 and beyond. We'll talk about the differences there in a little bit. In November of 2021, Microsoft Intune Remote Help was introduced. This is basically upgraded Quick Assist. It's a business-friendly version of Quick Assist. This will come into play later on. So remember that there is a pay version of Quick Assist. All right, so why are we even talking about this? Well, Quick Assist is being used by attackers to get into organizations. It's used in social engineering attacks. It has been used by Black Basta for ransomware attacks, as well as many other threat actors out there. Why? Well, because it's installed by default on Windows. If I am a random attacker and somehow this is how the social engineering attacks pretty much happen. You have your sharer and you have your helper, who is our hacker in this case. By the way, I love the PowerPoint cartoon figures. That is one of my favorite features of the new PowerPoint, but sorry. The helper, who is our hacker, says, hey, I'm IT support. Enter this code so I can fix your printer, because everybody's printer is always broken. This normally, or at least not normally, but in a lot of cases, this happens within teams. A lot of organizations have teams misconfigured so that external users, Teams users, or whatever you want to call them, can message internal users. And so an attacker will create an account like IT support, your organization name here, and then we'll start messaging the users and say, hey, I need to connect to your computer to fix it. The user says, sure, no problem, enters in the code, and now the attacker has access to their system. This is being, like I said, this is being used a lot by threat actors to get onto systems, to install backdoors, and then leverage basically their initial foothold. So that was a high-level overview of how Quick Assist works. Let's jump into it more, a little bit more in depth. I want to pull the covers back from Quick Assist a little bit, just so, because this is going to factor into how we can actually do things from a forensics perspective. So Quick Assist does have limitations. First off, the sharer must consent to letting the helper control their system. So when you connect via Quick Assist, the only thing, if the user enters in that little code, the only thing that you can do at that point is see their system. You cannot control their system. There's a little button that has to be hit by the helper that says that they want to control the system, and then a little pop-up appears on the sharer's side that says, do you want to allow the user to, or so-and-so to control your system? So they do have to click through. I mean, we know users, they're going to click through that anyways. If IT is telling them, hey, we need to control your system, they're going to let that happen, but there is at least that consent that needs to happen. Once that happens, the helper can control the system and they can chat with the user. There's like a little text chat feature. There's a couple other minor things, but like marking up the screen and so on. But the helper cannot transfer files natively to the system. You cannot transfer files natively through Quick Assist. You cannot copy and paste through Quick Assist, and the helper cannot click through UAC prompts. If a UAC prompt happens, the sharer has to click through it. And of course, if that happens, IT is going to say, please click through this, and they're going to do that. But the helper cannot natively do this. I'm going to put a little asterisk on this because I really truly believe that you can actually do this because of the underlying protocols being used. Nobody has just gone through the motions to figure it out yet. So where is Quick Assist? Quick Assist will live in one of two locations depending on the version that you have. There are essentially two versions of Quick Assist that I've been able to find. The first lives in System32. Both executables are called quickassist.exe. The one in System32 is installed by default in Windows 10 systems. I have not seen it outside of Windows 10 systems yet. To be fair, I have not had a huge amount of systems that I have been able to go through to find Quick Assist, but for the most part, in my observations, System32 means it was installed by default with Windows 10. There is also another version within Program Files, Windows Apps, Microsoft Corporation.QuickAssist _ and then a version number, the version of QuickAssist, followed by some more characters, and so on. This version is installed if you install it from the Microsoft Store, because it is in the Microsoft Store, or if you install it on a Windows 11, by default, I've seen it installed in this location. I have not yet seen it installed in the System32 in Windows 11 by default, but that doesn't mean you may not find it there as well. That's right, exactly. Yeah, good point. If they upgraded from Windows 10, you're right, then it would likely live within System32. There is a difference between these two. I will point out those differences as we move through this because they become very important. So authentication, how does that work? Well, there is a little bit of authentication that does take place. The sharer obviously is already logged into their computer, so they've already authenticated through whatever means is necessary. The helper does have to authenticate to their Microsoft account or Entra ID in order to help somebody. So whenever in QuickAssist you want to help someone, you click that little help someone button, this pops up, and then you have to sign in to Microsoft. Yeah, we're going to circle back to a lot of these. I'm just trying to lay the baseline for right now. So QuickAssist is running. What happens to all the processes in there? You know, how does this all work? So the user runs QuickAssist. It launches quickassist.exe. From there, QuickAssist launches a child process called msedgeweb2.exe, and it will have this parameter --webview-exe-name equals QuickAssist. msedgeweb2, or I think Microsoft calls it msedgewebview. I'm not a developer, so I'm probably going to get this a little bit wrong, but it's essentially a way for programmers to bring in web components like HTML, JavaScript, CSS, and so on into native applications. It's kind of a way to allow developers to combine, I'm going to say, the best of both worlds of having a native application but also having a web application. It basically allows them to do that. I'm not a developer, but if you're familiar with something like Beautiful Soup or libcurl or things like that, I have a feeling it's very similar to this. But it's used in a lot of places. If you have a EDR or a data lake, go through and look to see how many msedgewebview 2 processes you have. You're going to find a just immense number. But we know that this one is associated with QuickAssist because it does have the --webview exe name equals quickassist.exe. From there, our original child process launches a number of other child processes of msedgewebview. These may or may not have the WebView exe name parameter on them. Some of them do, some of them don't. So how do you know that they're associated with QuickAssist? You kind of have to look at the parent-child process in order to figure that one out. All right. Unfortunately, programs executed in the QA session, the QuickAssist session, are done under the normal Windows parent-child process. It is not done under the QuickAssist or msedgewebview processes. So what I mean by this is, when I was testing this out, I connected to a system via QuickAssist. You can see the QuickAssist processes there in the msedgewebview. Through that activity, I also launched Notepad and command.exe from the helper's computer on the sharer system. They were not under the QuickAssist processes. They were under explorer.exe. I believe this is very similar to how things like TeamViewer works and so on. So this isn't necessarily a surprise, but just to kind of hint at things to come, this also then makes it very difficult for us to say what processes the attacker executed versus the user. There's nothing to tie those two together. There are still ways that we can figure this out. Kind of. All right. Network communications. So, Quick Assist uses RDP as its underlying protocol. If you recall, Remote Assistant was basically RDP with some stuff tacked onto it. That's kind of how Quick Assist is. It is using RDP as the underlying protocol. However, it communicates over port 443 using TLS 1.2 and does not use 3389. Additionally, the sharer and helper never directly connect to each other. Everything is going through Microsoft servers. Specifically, the first one that's connected to, or the main one that's connected to, is this remote assistance.support.services.microsoft.com. So again, to kind of go through that session, helper wants to connect to the sharer. All of the traffic between the two is going up through Microsoft's servers and then back down. You might think, oh, well, I want to block this, so I just need to only block this, this particular website. Or if you want to allow it, you only need to allow this particular website. No. These are all of the or the Quick Assist servers that you need to allow to block or get it to work. I think actually if you were to just block remote assistance, that would kind of kill the connection. But these are all the things that need allowed. This is only for Quick Assist. Microsoft has a whole other slew of websites that need to be opened for MS Edge WebView. So it becomes a little bit cumbersome, I guess, on the allowing side if you only want to allow those sites that are needed for it to run. In terms of network monitoring, this also becomes a little bit of a nightmare. But, all right, I know I've been kind of going through that fast. Any questions so far? Cool. Yes?
You might get into this, but I'm just curious what kind of auditing there is.
We will definitely get into the auditing. Absolutely. You can tell by my laugh, it's bad. It's worse than normal Microsoft. It's yeah. So, and I am trying to be a little positive in this, but it's bad. It's bad. All right, so I taught the forensic class yesterday, and one of the things that I like to teach is when you're going into a forensic investigation, you should have questions in mind, because that's going to help you focus your investigation. And so I kind of sat down and thought, all right, well, if I'm going to do a Quick Assist investigation, or an investigation that involves Quick Assist, what do I want to know? You know, forensically, what do I want to be able to determine? So I want to be able to determine, was this system the helper or the sharer's PC? Because you're going to have different artifacts based off of that. And I want to say, too, that 99% of the time, you will probably, in an attack scenario, you are probably only going to have the sharer's PC. The helper's PC is probably the attacker, which you're likely not going to have access to. So keep that in mind. But more importantly, when did the Quick Assist session start, and when did it end? What are the time frames that I need to focus on for that session? Was consent given? Did the sharer allow the helper to actually control their system, or did they only let them view what was on the screen? Viewing what was on the screen could still be an issue, depending on your environment. But you know, it's not may not be as much of an issue if consent was not given. What was the user ID utilized and the IP address of the helper? Remember, the helper has to log in to Microsoft in order to use this. Do we get the user ID of that user so that we can go and do some more research or get them taken down or whatever? And can we figure out what the IP address of the helper is so that we can detect those malicious connections or find them? And then finally, what did the helper do? What was their behavior on the system? What did they access? What did they execute? What did they tell the user to do? And so on. So want to try to answer all of these questions. So event logs. First off, if you have the System32 version, there is nothing logged. Nothing in the event logs, nothing in a random text file, log file on there. There is literally nothing logged. Yes?
Nothing in terminal session in bitmap cache?
Nope. Oh, the bitmap cache, yes, but that is on the helper's PC, which you don't have access to because it's, yeah.
Yeah, because it's their share.
Right. Yes, so if you Google this and say, where can I find quick assist logs, you will eventually find one of those like Microsoft answer question help sites where I think random people will just like answer the questions and get credits or however that works. Somebody does say, well, you can go and look in the remote assistance event logs. That is not true. That is for remote assistance, not quick assist. Those are two different things. So unfortunately, the System32, I have yet to find anything actually logged in this case. Fortunately, the Windows 11 or the Microsoft Store version, you do get some logs within the application log. They are under the Quick Assist source. So if you filter it by Quick Assist as the source. All the event IDs are 0. And there is no defined structure to any of these events. In fact, if you go into Event Viewer and pull these up, where the data usually is, it is blank. You have to go into the raw view of the events in order to actually see any information. To me, this feels like somebody just randomly put in some debug and error messages to troubleshoot things, and that it's a mistake, that it was never meant to do this. So that means it could go away at any time. Hopefully, the opposite will happen where they'll get some more defined logs, but given what I've seen about Quick Assist, I kind of doubt that.
They don't know it's there.
They probably do not know it's there.
Like message by back in the day.
Yeah. This is another one of the reasons why I want to crack it open and look to see how these are being logged within the binary. But all right, so what do the event logs look like? This is the raw view. You've got the event source, the event ID, the event data. There is one that's logged that says quickassist.exe launched. This is the most normal of the event logs. This one I actually think you can see it. Yeah, it does give you a timestamp, so you can see when Quick Assist was launched. So we've kind of answered part of our questions already.
Is that 1250 unique to, like that's the entry of the event, and then you've got that process ID 3080. Do you only see 3080 in relation to Quick Assist? Or-
Yes.
Okay.
Yeah.
Cool. Good.
Yeah. So the process ID on here, you could tie it back to the process ID on the system. I don't have pictures of the error messages, but there are error messages that appear in here as well when you start launching Quick Assist. I have not found them useful at all. They seem to be error messages of like DLLs that loaded or did not load, and then nothing else. So they're really, they do give you an indication that Quick Assist was run, and if this was not in the logs, but outside of that, I have not found any use for them. The rest of the logs that you see are basically these like pseudo JSON events that have both a request and a response. Within them, there are a couple kind of important pieces. The first, you see this context command request response. That means that it's that system, which is we're probably talking about the sharer in this case, made a request. Or received a request. Actually, that I don't know how to figure out how that relates to things. I need to figure that one out, so sorry about that. But in any case, a command was created to a request to begin sharing. So you can tell, so basically, sorry. You have the command, request response. Sometimes that's a little bit different. And then you have the context of the command. You have context, response name, begin sharing. That's what is being requested. So in this particular case, this happens early on in the session where the helper is requesting from the sharer to begin sharing their screen. This is not a allow me to control your system. This is let's begin that sharing session. Then you have that connection string, which is a lot of base 64 and other stuff in there. Sometimes that contains information, sometimes it does not. Overall, looking at all of the event logs in this format, not everything is logged. So everything that is done within the session is not logged, and that connection string may be truncated. So there are times where you will see this connection string and then it just abruptly stops. There are times where there is readable information in there and then it just gets cut off. So something is truncating it. So this is the request. The response, will have the response name. This is going to be, what was the original request command, and then successful or additional data. I do not have a screenshot of this because I have not been able to confirm this yet. But there is one of these JSON requests that I think might have information about the helper system who is connecting in. However, that is limited to the operating system of the system that's connecting in. There is no user ID information, there's no IP address information, there's no unique identifiers. When I was testing it out, it basically said a Windows 10 system, and then it actually said it must have done something to look at the NIC or something else because it knew that it was a VMware system as well. The reason I'm saying I have not confirmed this yet is because I have not seen this done consistently, and I have not been able to correlate if it is in fact, pulling this from the sharer system or the helper system or someplace else. So I want to dig into that first. So there may be a little bit of information about the attacker system in the logs, but I have yet to confirm that, which is why it's not fully in here yet. So there are a number of these log messages that are useful. So we can tell, when Quick Assist was launched, because we get that Quick Assist launched message. When the sharer shares their screen with the helper, you see that begin sharing command, and then you'll see a response as to whether or not it was successful. If the sharer gives consent to the helper, you're going to see a request called set sharing mode, and the context information is sharing mode being full control. So we do actually get it logged when full control is requested. If there is a response that says success, true, then we know that the sharer did consent to giving the helper access to their system. If control is canceled or removed because the sharer does have the ability to kill that control at any time, you will see the set sharing mode set back to view. So you either have full control or view. By default, it goes into view because, again, when you first connect, the helper does not have the ability to access that or control the system. When sharing stops, you will get a request name of end sharing, and then when Quick Assist is closed, you will see something that says send app closed. So we do get a little bit of information. Remember, this is only in the Windows 11/Microsoft Store version. The Windows 10 default, if it's in System 32, you will get none of this. Yes?
Can you at least go into helper and see the pop-up launch if it's Windows 10?
I have not seen that yet. So the way that I tested this out, and I'm not going to say that my testing methodology isn't flawed. But the way that I tested this out is I had two systems, one a Windows 11, one a Windows 10, and then I connected back and forth between the two, and then I basically ran some triage software on it to pull everything out and then analyzed everything that happened between the times that I was doing this. I did not see those pop-up event logs anywhere. That doesn't mean I couldn't miss them, but I definitely did not.
They do it for OneDrive, and that's the way I've caught stuff in the past when there's a lack of logging. I know Windows 10 has that problem.
Okay.
And it's in registry, but it's just a helper box. So it's basically proving you had a pop-up. It doesn't give you anything else.
Gotcha. I will have to dig into that more. I don't recall seeing that, but again, I'm still this is kind of a work in progress. I'm actually hoping now that I do find that, now that you brought that up. But for the most part, at least talking event logs, this is what you get. Yeah. Unless, of course, Quick Assist crashes, and then you'll have all the crashing logs, but that's probably not going to happen. Yeah, well, you're right. It probably does happen a lot, but in a forensic investigation, I don't get that lucky. All right, but the helper had to authenticate, right? I mean, remember, the helper authenticates to Microsoft in order to see this. So that surely means that somewhere a authentication event, a security 4624, is logged, right? No, nothing is logged. I'm sure on Microsoft's side it is. And if you were lucky enough to have the helper be an IT user that was compromised and they logged into their Entra ID, then you would have those logs. But by default, we have some random attacker on the internet, probably connecting in through a VPN, through Quick Assist, and so on. We have no authentication logs. The most that we can tell that I've seen so far is maybe we can tell their operating system. What about file artifacts? Well, on the sharer side, there are actually a number of file artifacts that get created. And so far, this has been for both the System32 and the Microsoft Store version. First off, in program data, packages, the Quick Assist directory, SID, the user SID, system app Helium, you're going to have some files that are dropped in there, or at least that directory is created. The SID that is in the directory structure, this is going to be the user who ran Quick Assist on that computer. So if you didn't know, you probably do, but if you did not know, then you now have the SID of the user. There are two other directories within, first off, that particular user's directory to the same, very similar directory structure to Helium. That actually drops a registry file in there. I think it's actually a userclass.dat, although I could be wrong. It's either ntuser or userclass.dat. I don't remember which one. Same thing for the next directory, where it's instead of the users directory, it's in the all users directory, and the SID is in that directory structure as well. Unfortunately, so far, I have not found anything useful within those registry files. And I have gone through and made sure that the helper was opening files, executing programs, doing things that I would expect to trigger something in a registry file, and nothing is logged into those. You can use those registry files, though, the date and timestamps on them or within the last write timestamps of the registry files to get an idea of when Quick Assist was run, but it's not going to give you any information as to what was done in that session so far. Again, I don't know why these are created. There's a lot of unknowns with the why for some of these artifacts, just like with a lot of forensics.
Quick Assist, if the helper does something like launch a program, you're still going to get your normal
Yes.
artifacts, your link files.
Yes. Yeah. That's in a slide coming up. But yes, yes, you can timeline when the execution artifacts happen. You just cannot tie them specifically to the Quick Assist session.
Do we get anything that tells us when the session ends?
Yes, we do get something that tells us where the session ends. I know where you're going with this. We will definitely talk about that here in another slide. So, all right. This is probably the best file artifacts that are dropped. So remember that MS Edge WebView is based on Microsoft Edge, which is a Chromium-based browser. In this app data local temp remote help EB WebView directory on the sharer side, so it's going to be in their users app data local temp, you will find a bunch of the Chromium browser files. So the history file, cookies file, things that you would expect to find in a browser artifacts, you're going to find in this directory. This is great because we can then analyze this. It does have information in it. My preferred tool is Hindsight for Chromium browsers. It is amazing. They just came out with a new version which does a ton of stuff more. So you can actually find some good information in here. Particularly what I found useful, and again, I'm still kind of digging through all this, is within various, a number of the files, I think mostly in the history file, you will see access to the remote assistance.support.services.microsoft.com site. That does get logged into history. The first instance of this will occur shortly after Quick Assist is launched. So as soon as Quick Assist is launched, it makes that connection out to that Microsoft site. That does get logged. It's not exactly when Quick Assist was launched. You probably have to look at other artifacts like that Quick Assist launched event or prefetch or any other artifacts, but you can at least correlate it here. You will also see the access to that URL /screen share. This happens after screen sharing is enabled or the sharing code is entered. So when that initial connection happens, the user enters in that sharing code to share their screen to the helper. The browser, or the MS Edge WebView, is going to connect to the /screen share side or page. And then finally, when the sharing connection has been closed, it's been completely shut down, you will see it connect to /status/ended. I have not found anything within this artifacts to state consent, if consent was given, or chat logs, because remember there is some chat there. I actually have not found chat logs anywhere yet. To be fair, I wasn't specifically looking for that. That wasn't a top priority of me. Remember, this is my work in progress. But these are the biggest things that you're going to find within here. Again, this might change. This one does not feel like a mistake, unlike the event logs. There's going to be some things that that may continue to appear in here or may kind of eke themselves out. But this is probably, if you're going to grab something, this would probably be the best thing to grab. RDP artifacts. Remember that RDP is the underlying protocol here. Unfortunately, no RDP logs are created on either side. So if you're familiar with the way that RDP works, there are some event logs, the Microsoft-Windows-Terminal Services logs. There's, I think, about 8 to a dozen of them that contain a lot of information. Fortunately, nothing is logged in these. On the helper side, you do get the RDP cache. This can be, if you're unfamiliar with this artifact, it's a really cool artifact which basically RDP will cache the screen, screenshots of the screen, break it up into, I think, like 64 or a bunch of different little images that you then have to play, puzzle to.
Made a tool that puts them back together. Oh, it's right there. Oh, yeah.
Yeah, the RDP pieces. Yeah, yep. So there are tools that you can use to kind of help stitch it back together. Yeah. So the thing to understand, though, this is not on the sharer side. This is not the victim side. This is the attacker side, which you probably don't have access to. So, yes, exactly. So this does appear in some cases. Go ahead and look for it, but you're probably not going to get it. The registry side. I have seen that in the registry, in particular the user's registry, the user who ran this, in this really, really long key, there is a value called was ever activated, which gets set to 1 the first time Quick Assist is run. I think it will also, like every time you run it, it will go in and probably reset that to 1. So the last write time looks, the last modified time for that key is going to show you the last QA execution. So if you lost all other artifacts, you might get lucky and see this. And then actually, if you didn't have the event logs and the user says, I never connected to Quick Assist, their registry is going to, say otherwise. There is also under that key this ham AUI app v1lu with these values PCT and PTT that have some hex strings in there. I don't know I haven't figured out what those are. I think those are related to Microsoft applications. I need to hit up a developer at some point to figure out, what these are, because when you Google that key, the ham, AUI, so on, it shows up in other apps. So it's definitely something common that's happening. I just have not figured that out yet. And my Google skills did not figure it out either. So, all right. Execution artifacts. So you asked about this. Remember that, when we go into the Quick Assist session, when I launched Notepad, when I launched command.exe or anything else that the attacker would launch, it was under the normal parent-child process of Explorer. Because of this, all executed processes are going to be under the sharer's ID, the person the victim who's logged into their computer. Unfortunately, there's nothing in the process execution logging that is going to show what was executed by the helper. So if you have 4688 turned on, or sysmon process execution logs, or your EDR logs, there is nothing in there that I have been able to find yet that says, oh, this was executed from a Quick Assist session. The logon IDs, or the logon sessions are the same as the user. The desktops are the same as the user. It's as if the attacker was physically sitting next to the victim in this case. However, that doesn't mean we can't figure this out. So the way that you would do this, or the way that I would recommend doing this, is you first find the start of the Quick Assist session. When did this session start? We can do that through a number of different ways. We can look at the event logs. We can look at the application event log for Quick Assist. The MS Edge history files that I just talked about, those have that information in there as well. You can look at prefetch. You can look at the creation time of all the file system artifacts. If you have network activity being logged, you can see when that system goes out to that Microsoft site. So there are multiple ways that we can figure out when the QA session started. Then we need to figure out when did it stop. We have this in the application event log, the history files. We can look at the last modification date of some file system artifacts. You can look at network activity and so on. So there are ways that we can do this. From then, go back to the basics of forensics. Look for evidence of execution artifacts that occur between those times. So we've got prefetch, we've got SRUM, we've got 4688 in sysmon if they're turned on. There are multiple places in the registry, AMCAche, user assist, other places. There are lots of places in here that we can look to see what was executed during those two time frames. And then we figure out, look at the context of that. And I know we don't like to do this, but talk to the user. Ask them what the attacker did. Sometimes they'll actually be truthful with you. But it's very obvious that if you have some random HR person who this happened to, did they actually execute PowerShell? That's probably unlikely. It was probably the attacker. And so you can kind of dig into it and look at the context of what was being run based off of what was happening in there. The reason I'm talking like this is, from a forensics perspective, at least my perspective, I want evidence from the system that tells me who did what. I'm not going to rely on the user to tell me that. I'm not going to guess at that. So the more that I can prove based off of artifacts, I'm going to do that. And that's why I'm saying don't just assume that if PowerShell was run that it was the attacker. It very well could have been the user, depending on who the user is. But this is how I would go through and figure this stuff out. Network artifacts. Yeah, so everything goes through Microsoft servers. It is encrypted traffic. You may be doing TLS inspection in your environment, probably not based off of my experience, but everything's going through Microsoft servers. So you may see when the activity occurred, you may get the number of bytes that were transferred back and forth, but that's about the limit that you can do. Microsoft might have the data, but they only keep that for, I think, 3 days. And good luck getting that. Because everything is stored on Microsoft server, they say that, they even say in here, it's hard to see, but on their webpage it says no logs are created on either the helper's or sharer's device. And that Microsoft keeps an abbreviated version of the helper's name and no other information about them. So if you did want to find out who logged in to this to help your user, Microsoft has that information, but I have no idea how you'd get that outside of a court order or a subpoena or whatever you need, and good luck getting that within 3 days. So going back to our forensics investigations, we can answer some of these questions. Is this the helper or sharer's PC? Yes, we can do that. When did the QA session start or end? We can do that. Was consent given? There are some artifacts that tell us that. The user name, ID, or IP address of the helper. Unfortunately, we cannot do that. I have yet to find something that gives us that information. What did the helper execute or access? We can kind of determine that based off of that procedure that I showed, but there's nothing that gives us that direct evidence. So you're going to have to do a little bit of investigation to try and figure that out. I only have a couple minutes left, so I'm going to go through this pretty fast. Prevention. So what if you don't want Quick Assist to run in your system? Good luck. There are no native access controls for Quick Assist. Nothing. It either runs or it doesn't, unless you buy Microsoft Intune Remote Help, which is that business version. Then you get all the logging and all of the access controls. Of course, like Microsoft has done in the past, they put the security behind a paywall. Yeah, so I'll just move on. But there are no native access controls for Quick Assist. There are some things that you can still do. You can block access to the remote assistant site. This is also going to block access to MS Intune Remote Help, but if you don't use that, who cares? You can also uninstall or delete Quick Assist. Remember, this is installed on versions, this is installed by default on Windows 10 and Windows 11. You can go through and delete that or uninstall it. If you do need it, upgrade to the Microsoft Store version, so you at least get that weird, somewhat logging. You can also deny list this, and that's probably the best thing that I would do. In fact, I would recommend, if you're not going to use it, uninstall and make sure it's deleted, and then deny list it. And actually, I would recommend doing all of these. Deny listing it will at least allow you to, if the user decides to put it on or the attacker kind of, tricks them to putting it on back onto the system, this will at least prevent it from running. And then monitor for execution. That's kind of hard to do, though. And the reason I say that is the company I work for, we have a SOC, we have a big data lake. I went back over the last roughly 30 days looking for any place where Quick Assist or the MS Edge WebView processes were running for Quick Assist, and found over 2,000 matches amongst all of our clients within 30 days. I don't know how many of these our clients actually use Quick Assist officially. It's probably a very small amount. So it's probably getting executed a lot more times than we expect it to. That's another thing that I'm trying to dig into is what naturally within Microsoft would launch these processes. But you can still monitor for the execution. Some resources, the two that I want to point out really fast. Oh, actually, the first one is a gentleman who did some of this research already. He was the first one to, I think, publish anything for this, so I wanted to give him credit. The next two, LOL RMM and Strontick Encyclopedia, I actually found as I was doing this research. These are really cool sites which list out all the different RMMs and all the programs in System 32 and what they do, so that you can kind of whitelist that activity. Oops, sorry. All right. So that's it. The presentation is at that URL. We may have time for like 1 or 2 questions really fast. Yes? No? All right, we don't have time for questions. Oh, I'm sorry.
No, we do.
Oh, sorry.
We just want to make sure you get the mic, and then I'll run it.
So I have tried to remove the Windows 11 version of Quick Assist to varying levels of success.
Okay.
I've tried doing remediation scripts through Intune, both running in the system context as well as the user context. And I just am having a really hard time actually getting the Windows 11 version uninstalled. And I'm wondering if you have any recommendations.
I don't actually. So I have not gone through that.
Do you have an EDR tool?
Yes.
Just block it. Do an IOA, indicator of attack, and basically you can block it at the application layer where it won't run successfully, but it will sit on the box.
Yeah, that was going to be my suggestion is, yeah, use like a EDR or your app deny listing to block it at that point. The problem with uninstalling it is at some point you're going to upgrade Windows and it's going to appear back. So you have to go through that extra step.
I think the difficulty with the EDR solution is we use Defender, and blocking that is going to be a hash, and if it updates, that hash can change, but you don't want to block everything that's signed by Microsoft because Windows.
I think Defender has the option now where if you do a string block, you can block it not by hash and you can do file name. Check with them. But most EDRs have the string blocking now rather than hash. Yeah, and that one is what usually saves the day because you're right, every time there's a Windows update, Patch Tuesday, you're going to have to go back and do it again.
Any other questions? Yes.
Does the tool have a silent running capabilities?
Not that I have seen. So that's a great question. It's very in your face, which is why that this is usually happening within a social engineering attack. I have not yet seen a way to run Quick Assist silently in the background. When you run it, pop up right there. I mean, granted, we know how users are, but yeah, I have not yet found a silent running thing. The one thing I will say though is, I mentioned this in the front. RDP is the native protocol. RDP does allow file transfers and copy and paste. So I don't know where that blocking is happening within Quick Assist. If it's somewhere in the GUI front end, that means that we can probably backdoor through it and still do copy and paste. Nobody has just, as far as I know, nobody has figured that out yet.
I'm more worried about executing the Quick Assist with the code
Right.
and having them silently connect to somebody.
I have not yet seen that. I'm caveating that by I have not yet seen it. That doesn't mean it's not happening. Anyone?
So kind of like off of that, so after they're connected, it's not possible for them to like run programs in the background?
Oh no, it is.
Okay,
So
like
typically what's going to happen here in the social engineering attack, the bad guy is going to get consent to control the desktop. They're going to open up a command prompt and they're going to use the browser or something else, to curl or whatever else, to download programs and put their backdoor on the system. So
Okay.
at that point, think of it as just their way to get an initial foothold on the system. They're going to load a secondary backdoor, which allows them to do things silently.
Okay.
Yeah. Yes.
All right, we got time for one more.
So Quick Assist seems like one of these products like TeamViewer
Yep.
you've mentioned.
Yep.
And we recognize that it's an issue where a lot of people, especially vendors, are using these remote access tools. And we're trying to come up with a policy or a procedure on how to grapple with all of that. Do you offer anything other than blocking? Because a lot of times, they come back and they say they need it, right?
Yeah, I guess, I would, first off, if they say they want to use Quick Assist, tell them no, because there's no logging and access control around that. At least make them upgrade to the Intune Remote Help, because that gives you at least something. We talked about the technical ways to do this. On the policy side, I mean, if you have come up with a standard way that you will allow vendors to do this, to do remote connections, and make them use that, and make sure that it's something that has auditing, that has access control, and so on in it. But sometimes it comes down to contracts and policies to force them to use what you want them to use. So, all right, I think that's it. If anybody has any questions, I'll be around, but thank you.
All done.